Hello, I'm Zach. I work at Brilliant Soul. We're making smart insoles. They have pressure sensors, motion sensor, and haptics for feedback. And essentially, you buy them. You use their SDKs to build whatever apps you want. Health, sports, fitness, VR, what have you. And I'm just gonna walk you through some of the simple demos using the JavaScript SDK. So here, I'm going to add a device. This is the JavaScript SDK. Works in the browser. Easy to make web pages. So here I'm going to connect to one of the insoles. It's connected, and then I'm going to enable rotation data. And if I lift this, move this around, hopefully you can see the insole update in real time. And this one uses the magnetometer right now, so I guess if I calibrate it, moving it in a figure 8 motion, hold on its side. Let's see if I can open up the Compass app to see if the magnetometer is reading correctly. I just opened up the clock app. It seems to be aligned. Let's see. One sec. Yeah, so right now if I'm holding it, I think, it seems to be pointing towards north right now. It's kind of wobbling. And that can be useful if you're, you're walking, you can get a sense of what direction you're moving in. And then you can use the haptics if you want to make like a directions app. You can, as you're walking, use the heading of the insole's orientation to figure out what general direction you're going in. Take the average of both insoles, and if you want to, instead of saying turn right or turn left, you can use audio, or you can just say or you can just vibrate the left or right foot depending on whether you should turn left or right. There's also linear acceleration data, which we use here just to move it around. So if I'm moving it, you can see it. Let me zoom out here. Here, if I move it around, and that can be useful for some stuff. So I'm going to disable the sensors and show the pressure data. So here I'm going to look for devices. Got the right insole. I'm going to enable pressure data. So right now, if I squeeze on the pressure sensors, you can see the values light up. And it gives you a continuous value between 0 and 1, but for the actual ADC on the hardware, it's between 0 and 3000. The hardware is running, just conventional parts, Nordic NRF 52840. The IMU is BHI 260 AP, and the haptics are like the DRV 2625. Two independent haptics motors, one in the heel area, one in the toe area. You can see here the large black regions are where the pressure sensors are. One thing we got to work on the pressure sensors is to make them more sensitive, because right now if you press directly on the pressure sensors, you get pressure data, but if you press between the pressure sensors, you don't. So we want to fix that sensitivity so you can press anywhere on the pressure sensors or press anywhere on the insole and adjacent pressure sensors will light up. And these two circles over here show where the haptic motors are. Let's see. And we have, more sample pages. So if we connect to this insole, this shows you like the raw, the graph data. So if I press on the pressure sensors, you can see graphs. If I enable like the gyroscope in the linear acceleration, you can see if I move it, the gyroscope. And again, with our SDKs, you can do whatever you want to do with it. I can't give some, the first example I was just about to give is something that a startup is working on, so I don't know, it wouldn't be fair for us to say that. It's better to wait for them to build it so we can talk about it. With a JavaScript SDK, not only can you do it in the browser, but it works on Node.js, and that can be useful for web browsers that don't have web Bluetooth, like Safari, or which would include the Apple Vision Pro, because they use Safari, or the Oculus browser, for the Quest headsets. They don't have web Bluetooth, so you can't connect directly to them in the browser. Although, because our JavaScript SDK works in Node.js, we can make a WebSocket server where on Node.js it can connect to it through Bluetooth to the insoles and then relay the data over WebSockets. And then in some examples are, if I go to my channel here, let me find an example using, this one. Yeah, so this is an example of it on the Quest, where like I'm connecting to a Node.js server via WebSockets and asking the Node.js server to scan for devices, find them, and then as I connect to them, relay the data back to the Quest headset via WebSockets. So here, let me get to the part where you actually see the data. You can see us moving the insole in AR. So later on we'll be making some uh, we have a Unreal Engine SDK, and later on we'll have a Unity SDK, so more developers can access it because not all developers are web developers. We chose a JavaScript SDK first because it was the easiest to iterate on, and also by making by being able to have a Node.js server, not only can we relay the data over WebSockets, but we can also relay data over via UDP and via OSC. And with OSC, you can then relay the data to many other applications. One example is relaying the data to Maximus P, and then so you can use the insoles as a kick drum. Here this video has audio. You can let me know if you can actually hear the audio. Do you hear the audio? All right. I'm not sure I'm not sure if the HDMI is picking up on the audio. I think I can specify. Oh, so is able to do that? Yes. Yes. So you're able to hear the audio. Yeah, and here by connecting it to Maximus P via OSC, we can then use that data, like here the simple orientation data, to use it as a portable kick drum, where as you pivot on the heel or the toe, you can then trigger sound effects. And this is using a really simple example, although users, I don't know if you would call them developers, I guess you can call them developers, can take that data and use it to make some cool music. That's majority report stuff. Jesus. Another example in Maximus P is using it as a guitar pedal in Maximus P, where some musicians have reached out and they asked if you can use it as a guitar pedal. And I said, oh yeah, you can map it, you can pivot on the heel and map that to a pedal, like a distortion pedal. And they said, well, maybe, but normally pedals are uncomfortable because if you sit down and you pivot on the heel, or if you're standing and you pivot on the heel, that's not very comfortable. If your foot is away from your center of gravity, then pivoting on the heel is fine. But if your feet are close to the center of gravity, or if you're standing, pivoting on the toe feels more comfortable, and not even putting pressure on the toe, but pivoting on the toe, because if you want to use like your right foot as a pedal, you may want to put your weight on your left foot and then pivot on your right foot. And so this is a simple example of a distortion pedal in Maximus P. And hopefully you can hear that well. And again, this is a really simple example, and all the SDKs are open source, so you can take them, modify them, do whatever you want with them. It's good for us to make all these different applications, because some people would just be like, oh, we have the SDKs, you build all the demos, and then we'll share them and get attention. That's not very fair. And by us making the demos, that helps us iterate on the SDKs and on the firmware to make sure development is as easy as possible. And let's see, other examples. So those are the main idea of the web demos. This is our Unreal Engine plugin, and we're using a third-party Bluetooth plugin to connect to Bluetooth devices. It costs like $80, and it only works in iOS and Android. So you would think, oh well, then for developers, does that mean like you would use our Unreal Engine plugin, which the interface is purely blueprints to make development very easy? But you might think like, oh, so does that mean I have to build my app and then like build to my Android, or God forbid your iPhone, which takes forever to build, and that's not good turnaround. So our Unreal Engine plugin also allows you to connect via UDP to the Node.js server. So in this example, I'm going to run this thing, I can go to the here I'm able to scan for Bluetooth devices, which will work on iOS and Android. You can see here BLE is not supported because of the plugin, but by going on UDP, and I can connect to the Node.js server I have running right now. It's connected. Right now I'm going to scan for devices. If I'm on the left and right insole, here I'm going to connect to the right insole. It's connected, and then here I can, enable rotation. You can get the rotation data. I can enable, it's not position. I was using the linear acceleration data, but it still looks pretty nice. Enable the pressure data, trigger vibrations, and also the insoles can also run machine learning models on the insole using TensorFlow Lite. So if you can create your own machine learning model. We have some examples using ML5.js and Edge Impulse, which both work in the browser. For ML5.js, you can get the TensorFlow.js model, but you need to have like a Python server to convert it to TF Lite, because you can't do that in TensorFlow.js, which is kind of annoying. And so here we have a TensorFlow Lite model on desktop as a large UN8 array, and here we're going to send it to the insole right now. It's sending it, and now it's sent to the insole. And when you create your model and send it via Bluetooth, you can also configure what kind of model is it, classification or regression. You can specify the sample rate, like whether it's 20 milliseconds, 40 milliseconds. For our SDK, you essentially can specify which of the sensors you want to, sensor types you want to receive over Bluetooth or whatever. You can ask it every 20 milliseconds, every 40 milliseconds. You can send it in any increment of 5 milliseconds. Personally, I use like 20 or even 40. That's good enough for me, but if you want lower latency, you can do whatever you want. So here I'm going to enable the model. So now instead of streaming sensor data, raw sensor data to your desktop or smartphone and constantly running the model on your desktop, instead now it's running on the insole, and we have a simple gesture recognizer so it can detect taps, stomps, and kicks. They're designed to be put in your shoe, so it's kind of hard to emulate by hand, but here I'm going to try doing a tap, stomp, and a kick. All right. Some simple demos we have here. One is a little pitch flyer thing, where the goal is how can we wanted to experiment and see how can we use this as an input to games and stuff. So here what we do is we would take, here you would put this in your shoe. Essentially you would pivot on the toe and use that to move this object up and down. And here, let me enable it. And here the goal is to avoid the red circles and collect the yellow ones. Extremely simple. And this entire sample app that you're seeing right here was made purely in Blueprints. The plugin itself is made with a combination of C++ and Blueprints, but when you're making an app with it, you're purely doing, it's solely through Blueprints, because the goal is to make development as simple as possible. So here, the game is pretty simple but very fun. I let my little brother try it, and he would keep telling me like, "Oh, can you make it go faster and make more appear?" And he couldn't stop playing with it. The other demo we have is something called Tappy Bird, where you would just here you would pivot on the heel to move this up and down. So here I'm going to start it. Oh, whoops! Gotta try it again. So here you'd be pivoting on your heel. This one, unfortunately, I try to make it very close to like how Flappy Bird actually is, which is unfortunate because the game is hard enough. And so whenever I show people this demo, it's hard for them to try it and actually get far. So I'll try it again. Let's see. And here it's a little more forgiving, where if you hit any of the green pillars, it just knocks off some health. But if you do hit the ground, you die. And again, these games are extremely simple. And here I'm just looking at the pitch of the insole and just jumping it up if it goes above a certain threshold. So the game is very simple. And the third demo is this one uses the TF Lite model. Although I guess I'll just show you the demo. So here I'm going to enable the TensorFlow Lite model. And here you can recognize gestures like tap. And then here I'm going to go to the game, and then you would just tap when the things appear. If I don't do it, you get hit. So you have to make sure you... Oh, whoops. I tapped when I shouldn't. So let me restart. Yeah, it's again, it's hard to do when it's on the table. But this one, honestly, it uses the gesture recognizer to detect taps. Although, for this example, it's very primitive. You can just look at the pitch and just do it, manually. I chose to use a TF Lite model just to show an example of using, the gesture recognition in an actual application. And let's see what else. Oh, yes. There is one of the booths was this thing called Tap Tango, and is it? Oh no, Bot Tango, and it's like robotics. It's like they made this little app of like it's kind of like Maya or Blender animation software for robotics, like controlling the servos, and it works in real time. And so is it good? Oh, and it works in real time. So I met with them yesterday saying, does this have an API for connecting to external devices? And it's like, oh, well, it doesn't have like Bluetooth support. It's like, no, that's fine. I'll figure a way to pipe the data. And he said, they have a REST API. So this morning I made a simple little thing. So here's Bot Tango. Let me open up the software. Is this? Oh, I guess they changed the resolution here. It's kind of hard to see. So here I have the Bot Tango software. So I'm going to, I have a control here that represents a servo. I can barely see this. I think it'd be better to just show you the actual video I recorded. So what I did was, I was able to make a simple web page that would connect to the insole, just like all the other web demos, and it would take that. You can take any of the raw data types. Actually, I'll just show you what the web page looks like. Let's see. Let's see, Bot Tango. Yeah, so this is what the web page looks like. I would, connect to one of the devices, like the left insole. The right one is currently connected to the Node.js server. So I would connect to it. I can add a mapping where you can map any of the sensor types to one of the servos. And here you would specify like the name of the servo that is named in the Bot Tango software. Like my identifier is like the default name. And then you would specify like, go over here. And here you would specify like which of the values you want to use. And the ones I chose were like the orientation, yaw pitch roll, the linear acceleration XYZ, gyroscope XYZ, or any of the individual pressure sensors, or the center of pressure X or Y, which is just it gives you like an XY value of where the center of pressure is using a simple linear combination of the pressure sensors. Is very simple. So like one example here is like I would take like the pitch of it, and then I would set like I would enable game rotation, and then like as I change the pitch, here, let me reset this. Oh, I'm using the left insole. Whoops. Yeah, so here, like, as I change the pitch, you can see the value is between 0 and 1. And this is, it would then send the data, you would send the data from this web page to their REST API endpoint. Unfortunately, I can't do it directly from the web page because this is like HTTPS, which you got to do a secure connection to connect to Bluetooth devices. But you have to send it to an HTTP, like unsecure endpoint, which you can't really do that easily. So I had to like take that, send it to the Node.js server, and then have the server then send that HTTP request to the software. And I finished that a few hours ago, and I came to their booth, and they're like, "Hey, I got this working," and it's like, there's a lot of people here. We're really busy. Can you come back later? It's like, oh, sorry. And then now, because it's a little bit later, I stopped by their booth just now, and I recorded this video to show you guys, to show y'all. So here I'm going to full screen it, and you can see they have this bird, animatronic bird, that I wanted to control that with the insole, where like different components can control different parts of the bird. But we tested on just one little servo, and this is the video here. So here you can see as I change the pitch, it controls the servo on the right over there. And and here I'm going to change the mapping to a roll. And then now when I change the roll, it updates. So you can create like multiple mappings for multiple devices, left and right insole, and then you can configure like here I'm setting the so here I'm setting the pressure data for one of the pressure sensors. So you can see as I press on it, it goes down. When I release, it goes up, and if I squeeze in between, it gives you in between values. So it would be cool to see. So later on, when I go back later after this, to go back and try to come up with a larger mapping that can map stuff maybe from both insoles, and think about how you can use that for like puppeteering, because you'll see the thing moving and no one will know how you're controlling it because they can see your hands, you're not doing anything. So that'd be really cool to see. So you can, if you look up Brilliant Soul, you can find us. You can find us at brilliantsole.com. Right now we're still finishing up the hardware. We got to fix some things here and there, making the wireless charging better, because we have these wireless charging pucks that you put on the insoles, and they have to be just right. So we got to fix that. So if it's slightly off, it doesn't quite charge as well. And the thing with the pressure sensors of like making sure that you can press anywhere on the insole and you will get pressure data. Hopefully by the end of the year we'll have some solid dev kits that we would be proud of shipping to select developers with the small batch, and then later on scale up and order more and stuff. In the meantime, I'm just working on the software, making more SDKs. Right now we have the JavaScript SDK with the Node.js server thing. We have the Unreal Engine plugin, and later on to like use the OSC server to take the orientation data and send it to like VR chat, or take the UDP server and send that data to like Slime VR to use them as for full body tracking and VR and stuff. And then after that, just more SDKs, Unity, Python, what have you. And again, you can follow us online to see our progress. I regularly post demos of our progress and stuff. And I guess that's about it. How long was I going for?
Thank you very much for coming and talking about your project. I also want to mention that I remember you working on this at Noisebridge years ago, or what were prototypes of this back then, and it's so cool to see how far along this has come. And you guys when are you trying to get developer units out by?
Yeah, so I guess like years ago I was working at Yucatan, which was essentially the same product. Those were ESP32 based, and those had the electronics clipped on the side of the shoe, and the insole was just pressure sensors. This one is NRF based, and for these insoles, hopefully by the end of the year, we'll have like a small batch of dev kits to ship to some developers, because with a small batch. But hardware startups are unpredictable, and there's always things happening and stuff.
Yeah, we all know the hardware grind and like prototype, like limited run number, exorbitantly priced, like for doing runs of 20 or 50. Yeah, it's hard. I'm excited to hopefully try and get a developer unit at some point. I'd love to try these out skiing. As a longtime skier, it's a really cool product to see, and I definitely can see its use in like physical therapy, in rhythm. Like I could definitely see rhythm games, or as you showed with the kick drum demo. Yeah, there's a lot of really cool use cases for it. Thank you so much for showing off a demo.
Oh,
yeah.
Yeah, thanks for hosting me.